I did number 1 of the practice on the investigation video, so I'm going to do the practice number 3 and 4 for investigation number 2 here. So when I look at this polynomial that's in factored form, remember, to find the degree of a polynomial in factored form, you add the exponents of the factor, the multiplicities. Here I have a 2, a 1, and a 1. 2 plus 1 plus 1 is 4, which is called quartic. If I have degree 4, that means I have 4 roots. Now in this graph, the leading coefficient is negative. And because it's degree 4, the maximum number of turns is 3, 1 less than the degree. And the end behavior I'm going to come back to in a second once I do the sketch. Let's talk about the roots. You use the zero product law to find the roots. So this first one, negative x squared. If I were to take negative x squared and set that equal to 0, I would solve it for x by dividing by negative 1. You don't have to do this. I'm just going to show you. And then take the square root of x squared. Well, the square root of 0 is just 0. So anytime you have an x to an exponent, but there's no minus or plus after it in that factor, the root's always going to be 0. Now the multiplicity is the exponent on that factor. Here the multiplicity is 2. When you have an even multiplicity of 2, that means the graph is going to touch the axis at 0, and it's going to look quadratic. It's going to bounce off the axis and look like a little parabola. The next root here is the opposite of that factor at positive 1. Its multiplicity or exponent is 1. 1 is odd, which means you're going to cross the axis, and when you cross the axis, because of multiplicity 1, you're going to look linear. Right? Multiplicity 1 is like degree of 1, which is a linear function. Lastly, the last root here is at the opposite of 5, which is negative 5. Its multiplicity is 1, and same as the last guy, it's going to cross the axis and look linear. Now, let's sketch the graph. We can always use our calculator to look at a picture in a minute. But what I'm going to do is I'm going to plot the points here. I know that I have a root at 0. I know I have a root at 1. And I have a root at negative 5. Now, the degree of this is even. It's 4, which means that the arrows go in the same direction. And because the leading term is negative, both arrows are going to be going down. So when I make this sketch, my arrows are going to both end down. So what I have here is I have to start down. If I come up to the root at negative 5, I'm going to, based on my boxes, cross through and look linear at that root. Now when I get to 0, the multiplicity is 2. I said touch the axis. So I'm going to touch the axis at 0 and bounce off. That's how I look like a little parabola there. And I have to finish down at the yellow circle. I have to cross through the root of 1 and look linear. So I'm just going to go straight through. And that would be your graph. Now again, because both arrows are going down, that means the end behavior, they're both going to negative infinity. Now if you're not sure if you did that right, go to Desmos. Type the graph in here. We had negative x squared times x minus 1 times x plus 5. And that's what your picture looks like, which is pretty much what you drew, just it's really stretched out. You come up, down, bounce off at 0, and come back through at 1. All right, let's try one more, number 4. All right, this one, I add up the multiplicities. I have a 3, a 2, and a 1. So 3 plus 2 plus 1 is 6. If I have degree 6, that means there's a total of 6 roots. Here, the leading coefficient, there's a positive out in front. I don't see a negative, so my arrows are both going to be going up. So when I make my sketch here, both arrows are going to be starting up high, which means I'm going to skip to end behavior. Both arrows are going to be going to infinity because it's even degree positive leading coefficient. Maximum number of turns, if I have degree 6, is going to be 5. That's the most times that it could turn direction. Now let's talk about the root. At x plus 3 cubed, the root is the opposite of what's in the parentheses, which is negative 3. The multiplicity there is the exponent of 3. 3 is odd, so your graph's going to cross through. And think about this, the polynomial of degree 3 is called cubic. So my graph's going to look cubic at root of negative 3. At x equals positive 2 is the next one. Its multiplicity is 2. 2 is even, so you're going to touch the axis and look quadratic. Those two always go together. Finally, the last root's going to happen at negative 7. Its multiplicity is 1. 1 is odd, so you're going to cross the axis. And linear functions have degree of 1, so it's going to look linear. Let's make our sketch first by plotting our points. I know I have a root at negative 3. I have a root at 2. And then a root way out here at negative 7. I'm going to extend my axis. Now I know I'm starting up high. That's what I said my end behavior had to be. So at negative 7, when I come down, I have to cross the axis at negative 7. At negative 3 over here, I said I'm going to cross but look cubic, which means when I come up, I'm going to flatten out a little bit at the axis and then go up. You're not turning, you're just flattening out at the axis, going up. And then at x equals 2, I'm going to come down and touch and go back up to look quadratic. Let's take a look at that picture, because that one, let's make sure we did it right. So go back to Desmos. I can check my work by typing in parentheses x plus 3 cubed, and then x minus 2 squared, and finally x plus 7. All right, now it does what it should. It's hard to see based on the scale, but I do cut through at 7. I come up, and if I zoom in, you can see that I flatten out at negative 3, and then I come down here at 2. It's really, if I zoom in a lot, you can see it does come and look quadratic at 2. All right, so that is the practice for investigation number 2. There's lots of practice for lessons 1 and 2, so I want you to go ahead and try those, and then check your keys on campus.